Hi there! In a previous video I started to build this 2D racing game in C with Raylib, and this is how far I got. So we have this red car that I can drive around here and the camera follows it, and that's basically it. And I made the part 1 about 9 months ago, and I never made the second part because the video didn't get that many views. But recently the video has been gaining some traction, so I thought maybe I should make part 2. And speaking of traction, I would like this car to have a bit less traction. So I would like it to drift a bit. And in fact, I tried to do that already in the previous video, but I wasn't able to do it. But now that I haven't been working with C in 9 months, maybe magically I can do it now. So what do I mean by drifting? Well, as you can see right now, if I just turn around with this car, it turns nicely and it's very easy to turn this and it's easy to play, but it's kind of boring. And if I'm turning in a circle and then I stop, then it stops fairly quickly. But what I want to happen is this. Here we have some sort of Rally All-Stars game. And if I start this game, let's see how it works here. So here, if I start going forward and I turn and then I stop, then the car still like keeps turning. It kind of slides around like this. So that's what I want to happen. But I'm not quite sure how I can do that. But let's see if we can do it. So basically, if we are going straight, there, which actually we can go past the camera right now. Let me bring it back here. So if we are going straight and then we turn, then we should kind of keep the momentum going to the direction the car was going already. So it will drift in that direction if you turn really fast. So what I'm thinking is that we will add some sort of sideways force, or actually, well, it should be a force kind of to the previous direction where the car was going, and then move the car there in addition to moving it directly where it's pointing. So let's take a look at the code. How does this code work? So up here we have just our includes, and then we define some colors and some speeds and stuff. And then in the main, we define the window, make the window for the game, and then we define the width of the world and the height of the world, and we load some images. So we have the background image here and then the car image here, and we define the texture for the car and stuff like this. And we have the width and height of the car and the position of the car and the speed and the maximum speed and the direction, whether it's going forward or backward. And then we have the rotation, and we have a speed up and a slow down. And then we have the camera here so that we can move the camera around. And we have our main loop here where we just clear the background, we start the camera, and we draw the background tiles here. And then we check if we are pressing up, then the car direction is going to be -1, and we add to the car speed. And we check if the car speed goes over the max car speed, then we just set it to max car speed. And if we press down, then car direction is 1, and car speed will be subtracted. And again, we check if the speed is too high, then we set it to the max speed. And then otherwise, if we're not pressing any buttons, then we are going to slow down the car. And then if we are going up and the car speed is less than 0, then we stop the car. And if we are going down and the car speed is more than 0, then we set the car speed to 0, so that it stops ultimately. And if we are pressing left, then we just rotate the car to the left, and if we press right, we rotate the car right, or clockwise, and left is counterclockwise. And then here we just set the rotation to 0 when it goes over 360, which I'm not sure if we need this, but I added it in the previous video because of reasons. Anyway, then we calculate the direction where the car should move. So we convert the car rotation into radians, and then we calculate how much we should move in the x direction by doing car speed times the cosine of the radians. And then in the y direction, it's car speed times the sine of the radians. And then we just move the car in that direction. And down here we do the camera stuff. So the camera will follow the car. And then we just draw the car down here. So what I think we should do is we should add here another part where we move the car in some direction. So we will move the car in the direction of the rotation, but we will also move the car in the direction of the drift force, or whatever you want to call it. Let's call it drift angle. And we can probably reuse these radians. We don't have to define these here, and we can use the X move and Y move. And we can probably just do this. We can directly plus equal it like that. So we don't have to have so many lines of code. And we can do the same thing here and over here. So this one is move car in direction of car. move car forward. And then this one is going to be move car to direction of drift. And then we have to make the drift angle. And what is a drift angle? Well, let's open the game again. So if we are going straight up like this, and then we turn over there, then the angle of the drift should kind of be the previous angle. Or the drift angle should follow the real angle. It should like lag behind. So if we're going this way, then the drift angle should be kind of over there. So over time, the drift angle should go to the angle of the car. So let's do this. Let's define the drift angle up here. Let's say float. What is that? What am I writing? Float drift angle is at first the car rotation. Car rotation, which I might want to call this car angle just to have the same naming. So let's call it car angle. So we start from that. And then we have to move the drift angle towards the car angle, which at first it is the same, but on the next frame, if we turn, it's going to be different. So can't we just use an average? Can't we say something like this? When we calculate the car angle, then we say that the drift angle is going to be the car angle plus the drift angle, and then we divide by 2. And we have to, of course, put parentheses here. So this is basically the average. So then it should move closer. Now, it might be a bit too fast like this, but let's see. If we just print f here, let's print both of these things. Let's print the car angle and the drift angle. And let's see what happens. If we now build the game and we run the game, and we turn like this, and we take a look, we have some numbers here. They're basically the same. Are they different at some point? Here they are a bit different. Okay, so now the drift angle is coming behind the actual angle. But it kind of seems like on every frame it's catching up already. So I think that's too fast. So can't we add some sort of bias to this? If we say drift angle times drift bias, for example, and then we divide this by 1 plus drift bias. So it's like we are adding more of these drift angles into the average equation. So it's going to be more biased towards the drift angle. I'm not sure if there's a simpler way of doing this, but at least we can do it like this. So then if we define here float drift bias, and you put here like 10, for example, then now if we build the game and we run the game, and let's move the game over here, and if we now move this around and then we stop, then now you can see it's still going up slowly. So now the drift angle is going to be lagging behind, and actually already kind of drifting, but something weird is happening. I'm not sure why it does like this. Now, there might be a problem here because we are setting the angle to 0 here. And the reason why I did this was kind of, well, first of all, it's kind of nicer to have just the angle from 0 to 360. But I think with the math, it works out even if it's like 10 times 360. But I thought that maybe like the integer will overflow or something at some point if we turn around a quadrillion times, then it will overflow and something bad will happen. Maybe that is not a thing that happens. So let's remove this thing. Let me know in the comments if that's a stupid idea or not. Let's see what happens now. If we now run the game, and let's move this again to the side so we can see the numbers. And now we do like this. And actually, look at this thing. It's going in a bigger circle, and it's like, it is drifting kind of. Yeah, it looks like the back is kind of loose when I go in a circle. That's pretty cool. But now when I stop, it just keeps going forward. So how do we fix that? I think first of all, we should change the slowdown to be much lower, because I want it to slow down slower. So if we do just 5, and then we run it, and then we stop, then it's going to slow down like this. Okay. Which kind of makes it more difficult to play, right? Because it's going to keep going. Okay. But still, if we go around in a circle and then we stop, it just goes straight. I want to keep turning. So currently, how we turn is we just directly change the car angle when we press left. But should we do it in a way that we add to the angle of the kind of the steering? We have like a steering angle, and then we move the actual car angle towards the steering angle over time. So let's define another one here. Let's say float steering, and let's not use actual angles. Let's just use a number, like let's start with 0, and then let's copy this equation. And when we press left, we are going to just say that the steering minus equals or plus equals, I'm not quite sure which one, probably minus equals something. Let's call it steering speed. And we probably want to add the times dt here. And let's define the steering speed, float steering speed. And let's just use something like 5. I'm not sure what numbers to use here. And when we press right, then steering will plus equal the steering speed times dt. And then we are going to rotate the car with every iteration of the loop, so with every frame. We probably don't need the dt here now. So the dt is the delta time. It's the time in seconds between the frames. And we use it so that the speed will be the same no matter the FPS. But if we have it in the equation already here, we probably don't need it here. So then we move the car angle towards the steering angle. So like if the steering is negative, we subtract. So this probably should be plus now, because we have the minus here already. So we can just add to the car angle the steering. And the car speed is here so that it will not turn when the car is stationary. So I feel like this should already be here, in fact. Because when we add or subtract from the steering, that should only be done when the car is moving. Okay, so then we add to the car angle the steering amount. But we should have a maximum steering, because now it just keeps going and going. So let's do something like, when we turn left, if the steering is less than negative max steering, which kind of is this rotation speed that we define here. I might want to remove this definition. I will just say float max steering is 20. So then, if the steering is less than negative max steering, when we turn left, then the steering is going to be negative max steering. And when we turn right, then if the steering is greater than max steering, then the steering is max steering. So this means we are going to turn 20 degrees per frame at the maximum now, when max steering is 20. But now, if we leave it at this, the steering will be remembered. So if we stop the car and we continue, then it's going to keep turning that way. Let's actually see what this does. If we now build it and we run it, and then we go forward, we can go forward, we can go backward. And if we turn like this, then whoa, It's spinning around. Can I undo the spinning? Yes, I can. But it keeps spinning a lot. Wait a minute. Why is it still spinning? Because the steering is still like the steering is remembered, right? So we have to, if we don't press left or right, we have to kind of move the steering wheel back to the middle. So can't we use the same thing here as the drift angle formula here? We can say that the steering equals, well, actually this is even simpler. We can just say steering equals steering times some number, 0.5. And do we need to use the dt here again? I think we need to use the dt here again. So this means every frame the steering will have. So maybe we want to have an even lower number here. Sorry, a higher number, 275. And what is this? This is like the steer back speed. I guess we should name everything, but I don't know if this makes any sense. Float steer back speed is 0.75. But if it's called steer back speed, then it kind of sounds like it needs to be a bigger number for it to steer back faster. So we could put like 25 here, and then we can put here 1 minus steer back speed. So that maybe makes more sense. And let's then try. Build it and run it. And now if we turn, it will not turn at all. Why not? Wait a minute. I think the problem here is that we are using dt, which is a very small number. So this will basically always be 0. Do we even need to use dt here? I'm not quite sure. I feel like we do need to use it. Let's see if we remove it. What will happen? If I just remove it and I build it and I run it, then can we turn now? Now we can turn. Okay. But I feel like it's wrong. It's gonna change now how fast it turns back if we change the FPS. But now we're making a very large circle here. And I do feel like I want it to turn even more after it stops. So if I stop now, it doesn't actually keep turning. So I think this is too fast. So the steer back speed needs to be something like, let's just put 1%. So let's build it and run it. And now if we turn, it's too fast. Okay, but it slows down over time, very slowly. So let's put something like 2. Let's see what happens. Sorry, not 2, 0.2. No, we used 0.25 already. That was too fast. Let's put 0.1 and build it and run it. And then turn it and okay, it disappeared, but I think it looked pretty good. We need to add some protection so that it can't go off screen. But if I now turn, it's drifting a lot. We're doing donuts here. And if I stop, then it keeps turning. I want it to turn even more. So let's put 0.5 here, or 0.4. Let's build and run. And then if we, oh my God, it's running. Okay, at least it drifts now. I mean, it keeps, when I stop, it keeps going around. But it's too fast. Maybe max steering is too much. Let's put just 10. So it's turning, why is it turning faster now? Because before it was 10 too. Okay, so that's better. So now we're doing donuts here again. And if I stop, then it keeps going a little bit. That's pretty cool. So let's put max steering even at 5 maybe. Then build and run. And then it goes like this. Now it makes a bigger circle. And if I stop, it keeps going like this. That's pretty cool. So what I will do is I will make the steer back speed even a bit lower, and I will make the car slow down a bit faster. Which we could probably just, like, how did we do the car slowdown? We add to the car speed the car slowdown. But can't we get rid of all this stuff by just saying that the car speed equals car slowdown times car speed? Do we need the dt? I feel like we need the dt. I'm not sure. Car speed. And then we made the car slowdown like a percentage. So now car slowdown is going to be like 0.95. So then we don't have to check anything. If it is going this way, then make it 0 and stuff like that. We can just build it and run it. And now if we do like this and we stop, then it still keeps going. Yeah, that's cool. But it's a bit weird in the end. So if you do like this, it is drifting very nicely. If I stop, yeah, it turns a bit too fast. And it keeps turning for too long. Okay, but I think 95 is pretty good here. Let's put steer back speed to 0.04. Maybe that was good enough. So now if I go like this, it will drift nicely. And if I stop, yeah, it's somehow in the end, it's kind of too slow to stop turning. But otherwise, it looks pretty good. So does it just mean that I have to put it like 0.08? Build and run, and then I go and I stop. Okay, that's pretty good. Is it? Let's see again. If I stop, yeah, pretty nice. I guess if we make this car slow down like 99, then it's gonna go further. I'm not sure what is the correct number here. So now it's gonna slow down very slowly, but it doesn't turn as much. So we need to tweak these numbers to make it correct. Let's put 97 here and let's put 4 here. And then build and run, and then it does like this. And if I stop, it's pretty good. It's pretty good, I guess. And what if I change the drift bias? What if I put 15? Then it will lag even more. So it should kind of drift more, right? Okay, so it will actually, it will make a tighter circle, but it's kind of drifting more. Okay, that's pretty cool. Isn't that's drifting, that's definitely drifting. That's really cool. I think the car is a bit too fast, but yeah. And maybe that is, does it turn too quickly? It kind of looks weird when it turns. Maybe the steering should be slower. So the steering speed, yeah, steering speed should be just like 2 or 3. Let's build and run. So now it's gonna start steering slower. So now it looks better when it turns. It doesn't turn too quickly. That's pretty good, I think. What do you think? Maybe it's hard to see in the video how it actually feels, but I kind of like this. At least we can tweak these numbers to make it go properly. Maybe it turns too fast. Maybe max steering can be just 4 and car speed or max speed can be just like 7. And let's see how that will work. So now it will move this way, which is kind of nice. It's really drifting. That's very cool. Yeah. Let me see how well I can drive this. If I want to go like through these 2, what are these, like tree stumps? Can I go through them like this? It's pretty hard to drive, which I guess is good because it makes it more difficult to drive this car. I can't go through them both. It's too hard. And I guess in the game we should have something like you could buy better wheels or better suspension or something like this, and then it will make it drift less, so then it's easier to play over time. Isn't that what they do in games like this? Anyway, it's nice. It's kind of difficult to play, and it looks great. So what's next? Could we add some tire marks? That would be cool. Especially when it drifts. It could make like a skid mark as it drifts. How can we do that? But before I do that, I am going to remove my printf from here. And I am going to commit these changes because now it's drifting and it's working. So let's git add p, and we removed rotation speed. And we added all these things. And we added the drift direction. And we changed the car rotation to car angle. Okay, that's it. Git commit m added drifting. So how are we going to draw skid marks? This seems like it's going to be very difficult, at least to make it look nice. But at first, what we could do is we could just draw some circles or rectangles, I guess circles, in the positions of the back wheels of the car when the car is drifting. So how can we do that? Down here, in the end of this window should close loop, we are drawing the car. So let's just try to place a circle in both of the wheels, on top of the wheels. Of course, they will have to be under the wheels in the end, but at first let's put them on top so we can see them. So we need to figure out the positions of those wheels. And we're drawing the car here. We draw it in the car X and the car Y. And the width is actually car height. I think this has something to do with the angles and how the sprite of the car, the image, is drawn, or how the image is rotated. Which is kind of stupid why it's like this. And let's actually see. So the car height is longer. So the height is actually the width. Like, what is the width of the car? This is in fact the width. So let's say that this is the width, and this is going to be car width. So this is then going to be the car height. So now it makes sense, right? I think originally I used the car height as the height of the image. But of course, you don't speak about the height of the car that way. It's not height, it's the length of the car, right? So let's call this the length of the car. Car length. That makes sense. Except it's still wrong. Damn it. What do we call these things? Wait a minute. Car height is car length, right? The length of the car. And then the width is going to be car width. Okay. Doesn't that make sense? The car is this width and this length. So now it makes sense. And we start the car in the middle, which is the width of the screen divided by 2 minus the width of the car divided by 2. And the y is height of the screen divided by 2 minus car length divided by 2. That makes sense. So then, in the end, we're going to draw a rectangle that is the width of the car length. Okay. And the height of the car width. But why is it like this? I don't really understand why is it. Maybe the image. Let's look at the image. Where is the image? Car. The image is this way. So how can we draw a rectangle that is more wide than it is tall? Let's actually run this game again. And we draw it this way. I really don't understand why it's like this. How do we load the car texture? I really want to know why is it like this. So the width of the rectangle of the texture is width car texture width. Okay. And height car texture height. And where do we use car texture rec? We use it here. So we load it from the image, and in the image it is facing upwards. And then the rectangle has a width of car texture width. Okay. We rotate the image clockwise here. Why do we rotate the image? Let's see. If we don't rotate the image and we load the car image, and then the texture is the width of the texture. The rectangle of the texture is the width of the texture and the height of the texture. That makes sense. And then down here, can we now say that the width is the car width and the height is the car length? So now this is upwards as well. So now the car will be in a different angle now, right? But it should still work just the same. So now the car is facing that way. But if I go forward, yeah, okay, this is the reason. If I now say that the car angle is going to be 0, and then I build and run, now it faces upwards. But it goes there. Okay, that is the reason why I made it that way. Because the angles, based on the calculation of the sine and cosine, that angle points to a specific direction that I cannot change, right? I can't change where the car moves based on this cosine and sine, right? Unless I do car angle minus 90 here, right? If I do something like this, minus 90, and then I build and run, then now it goes, okay, should I do that? Because now it still works. And now the rectangles kind of make sense. Maybe I'll leave it like this. Okay. So now when I start the game, it's still going upwards, and now the rectangles make sense. Great. So I'll commit this change also. Git add p. I will not rotate the car image, and I will call this length instead of height, and then this one starts at 0. Okay. So now 0 is up. Maybe that will cause some issues later on. Or is 0 up? Why wouldn't 0 be up? Maybe 0 is not up. Maybe 0 is to the right. Whatever. I want to make the rectangles make sense. Okay, so we subtract 90 degrees from that. And then I want to split this one, and I want to only take this and that and not this one. Git commit m made rectangles make sense. That's a great commit message. So now we can draw the skid marks on the wheels. So we're going to have a float left wheel or tire X is something, and left tire Y is something. What is it? At first, since the car is upward, the left tire X is going to be car X. In fact, car X. Basically, it's going to be car X. And Y is going to be car Y plus car length minus something. Because what does the car look like? Let's take a look at the game. Okay, so we can't actually see the wheels from this angle, but the wheels are somewhere like here. So we need to subtract, I don't know, 20 pixels. So let's try to say that car Y plus car length, which is all the way in the bottom, minus 20. And let's actually put car X plus 5, something like this. And then let's draw a circle there. So draw circle, not 3D, just circle. And center X is left tire X. And center Y is left tire Y. And radius is like 10. And color is, let's make it black. And let's see if this works. If we now build the game and run the game, then it is absolutely nowhere close to what I want it to be. It's here. How come? If I put car X plus 15 and I build and I run, did it even move that way? Wait a minute. 35, build and run. Yeah, it does move that way, but why does it do that? That makes no sense. What if it's just car X and car Y plus car length? Build and run. Now it's there. Can it be flipped? Like, but it's, wait a minute. That makes no sense to me. Is this still wrong? So the width is the car width, right? And height is car length. How come that is not in the right place? Is it because of the camera or something? Or is it because of the car origin? Does this change not only the rotation, but from where it is drawn? So if I set it to 0 and I run it, that's the reason. So if I would set it like this, then if I rotate it, it's going to rotate like around that axis, which is kind of weird. Yeah, so I need to set the origin like that, which means the X needs to be offset by car. And wait a minute, this origin is now screwed up because the car width should be the X, right? And car length. I'm pretty sure it should be like this. Oops, I forgot to add here. Minus, let's just add it here for now. And let's build it and let's run it. So does it work properly now? Yes, now it still works. I think it didn't work properly before. It rotated from a different angle. So let me do git add p again, and I will add only that part. So S to split it, and I only want to add this. And I want to say git commit amend, just amend. And now we have a nice git log. So that makes the rectangle make sense. But now the car X needs to have minus car width divided by 2. Right. Let's build it and let's run it. So now the X is correct, right? It's basically correct. I'm not sure how much like space there is in the image, right? There's some space in the image, so we have to take that into account in the edges. Okay. And then this should be car length minus car length divided by 2, which I guess I can just say car length divided by 2. And then I can build it and I can run it. So now it's there. Okay. But of course, we need to move that position when we turn the car, because now it's always there. Okay. And first of all, let me make it 5 pixels. And let's add here that 5 and subtract here that 20. Build and run. Okay, it is right there. So I will, in fact, make it a bit bigger. Let's put 8. And I want to subtract a bit more, 25, and put here 10. And then build and run. Okay, now it's in the spot of the tire. But maybe it's a bit too big, so let's put 6. And then build and run. So now, that is kind of the point where I want the skid mark to start, right? Maybe a bit higher, 27. But how do we move this based on the angle of the car? Can we rotate the circle? Is there draw circle pro? There's no draw circle pro. There's draw circle V. What does that do? It just used the vector 2 for the center, which doesn't help us. Draw circle lines, sector lines. What is lines? It's probably gonna just draw the line around the circle. So we need to use math. Oh no, we need to use math. How can we math the tire in the right place? Let's take a look at the game. Right now it's there. If I rotate the car, then that needs to move up. It needs to move down and to the right. Let's take a picture of this and open it in some photo editor. And let's open this somewhere in Photo P. And let's start a new project and paste this in here. So how does this thing work? So if we would rotate this car, let me grab the car and let me rotate it. It will rotate like this. So then that means the dot should move from there to there. And what is the angle? The angle is like this. This is the angle of the rotation. So how can we position this triangle so that it will tell us where to move this wheel? Okay, I think we could imagine that we were moving from the middle of the car down here or up here, however we want to imagine it. Because I know how to move the point from the middle of the car towards where the car is pointing. So then I can determine this position, and when I have that position, then I can maybe determine that position as well. So, man, let's imagine. Here we have this thing where we move the car forward. We know this formula. So if I go down here, let's say radians is again the car angle. So we could say that the left tire X is going to be car length, car width divided by 2, which is in the middle of the car, times the cosine of the radians. So if we would do like this position would now be in the front of the car. Are you following me? I'm not sure if I'm following myself. And then if we do the left tire Y, we can set it to the car length divided by 2, which is again in the middle of the car horizontally. And if we do times the sine of the radians, and sorry, that should be car X plus this, and car Y plus this. So we start at the X, in fact, we start at the car X plus half the width of the car. Okay, let's do this. Let's start here. The left tire Y, or left tire X, is going to be car X plus car width divided by 2, which is in the middle of the car. We'll start there. Then if we do left tire X plus equals car width divided by 2 times the cosine of the radians. And we do the same thing with the left tire Y. So we start with car Y plus car length divided by 2. And then we do left tire Y plus equals the car length divided by 2 times the sine of the radians. Then what will happen is it is as if we were moving from the middle of the car towards the front of the car. So this means that now this point should be in the nose of the car all the time. Do you get what I'm saying? Now it's not in the right place, but at least I know how to get to that place. So maybe then we can determine the other places as well. Except it's in the wrong place now. Why is it there? Damn it. Let's try again. So if we now build this and we run it, why is it there? If we start with car X plus, maybe we don't have to do this because we have the origin. Wait a minute, but it should still work. Why doesn't it work? This should be minus. Right. How about here? We always use plus equal. Okay, but of course the Y position need to start with car Y. No, it's plus. Car Y plus car length. Why doesn't it work? I thought it's gonna work. It definitely does not work as I expected. Let me just do this. If I remove these parts and then I build and run, why is it there? I don't get it. If I use just car X and car Y, where is it then? Is it now in the middle because we use the origin? Now it's in the middle. Okay. So now, if we were to move this ball to the direction of the car, wouldn't we do it this way? We have the angle of the car, and then we add to it this one, which is half the width of the car. Sorry, this needs to be the... Okay, this needs to be the length in both of these. Both of these needs to be the length divided by 2, because the length divided by 2 is this distance, right? Approximately. And in the above example, in this moving the car forward, we use the car speed. And here the car speed is going to be the distance it moves. So now if we move it towards the front of the car by half of the distance of the car, it's going to be in the front. Now we run it. Look at that. Where is it? It's exactly there. And if I turn, look at this. It is staying right there. What did I do? I'm an amazing programmer. Okay, so how do we make it go to the back? So what if I move the x to car x minus car width divided by 2, and then I add that, what did we use, 7 I think it was. Is it then going to be up there? It is. And does it stay there? It does. No, it doesn't stay there. Damn it. It doesn't stay there now. Why doesn't it stay there? Because it turns, so it doesn't stay there. Did this help at all? Okay, so that is not going to work this way. Now we build it. Now it's always there. So how can I make it point to a different direction? If I change this angle, if I put like 100 here, does it then go to a different place, but does it stay there? It does stay there, right? Does it? It does. Okay, so if I move this angle randomly, I can make it go to any place I want, which is almost in the right place. Look at that. It's in the right place, almost. So if I now say car length divided by 2.1, and then I build and run, it moved a little bit somewhere. Let's put 2.5. Okay, now it's there. It's almost there now. So now if I do 260, or maybe the other way, yeah, the other way, 240, then now it's going to be exactly there. Look at this. If I wanted to move a little bit, then I can put here 2.6. This is such amazing math. Now look at this. It stays there all the time, in the right place. I'm such a genius. So now, that is the left tire X and Y. So let's make the right tire X and Y. What is that going to be? Don't we just change the angle? So we need to change it with, what is the angle? Okay, we should be able to determine this by math. What is the angle? If this one, sorry, it's this way. If the point is right now pointing from the middle of the car into the left corner, but we want to point it to the right corner, then here it's like 40 degrees or something. So this needs to be 280. Oops. I need to call this right tire Y. And then build it and then run it. And it is almost in the right place. It's probably 45 degrees then. Or maybe it's even more. Let's put 290 and let's just guess our way into the right place. It's 310. Build and run. That's too much. Just 300. Look at this. It's in the right place. And they both stay there all the time. Exactly there. So now we have 2 points that are following the car, and we definitely did it the right way. There's no easier way of doing this. So then what we have to do is we have to draw the circle there and leave it there every frame when the car is drifting. So how do we do that? We need to have an array of these things. We need to make an array in C. How do we make an array in C? We need to make an array of vector 2's, right? The X and Y positions. So a vector 2 is in Raylib, it's a structure that has an X and a Y, like this. So if we make a array from vector2. How do we do that? Do we just say vector2 skid marks, and do we define it this way? And then we say how many we want to store in this. So how many do we want? I don't know. 200 skid marks. Maybe even more. Let's put 255. That's a nice number. So this will like allocate some memory somewhere, I guess in the stack, if I know anything about anything, which I don't. So we're going to now have an array of skid marks. And then we can, down here, let's move these drawings out of the way. And here we calculate the positions of the skid marks where they should be. And we can say that skid marks, and we have to index it somehow. We have to say skid mark count equals vector2 that has the left tire X and left tire Y. So actually we don't need a vector2, we need 4 items. Should we create our own thing? So we can say type def skid mark. And how did this work? We do something like this and then skid mark. I think it works like this. Or is it type def struct skid mark? This way. And the skid mark has the left tire X, which is a float. Float. And do we need to define values for these? Maybe not. Float left tire Y. I haven't been working with C in 9 months, so I don't really remember. And before that, I haven't been really working with C quite at all, so I don't know that much about C. So float right tire Y, sorry, X, and float right tire Y. And these probably should be semicolons. Okay, so now we have this kind of struct. So then we can make this thing an array of skid marks. And then we can create our skid mark. We can say that we add to the skid marks a skid mark, which has left tire X, left tire Y. Sorry, it was written this way. Can we do like this, and we can do right tire X, right tire Y. Then we can say skid mark count plus plus, and we have to initialize this somewhere. So let's say here that we have a skid mark, and it's int skid mark count is 0. And then we just add to this array on every frame. And then we have to draw all of them. So then we do for int I equals 0, I less than skid mark count I plus plus. Right, and then we draw the skid mark. So we can say that the skid mark is going to be skid marks index I. And then we can say skid mark dot left tire X and right tire X. Right, isn't this how it works? So then we draw all of the skid marks. But now we have the limit of 255. So can we do something like if skid mark count is greater than 255 or greater than or equal to 255, then skid mark count is 0, which does something weird, I guess. Well, let's see what will happen now. Look at this. We have skid marks. We have skid marks, and they disappear when we get 255 of them. What? That's pretty cool. Okay, so that's not really the way I want to make them disappear. I want them to disappear over time. So how do we do that? We could just say skid mark count modulo 255, right? So is that how you do it? So if you do modulo, then it will roll over. Is that correct? So how does modulo work? Let's use PHP interactive shell, and let's say echo 0 modulo 255 is 0. Then it's going to be 1, it's going to be 1, it's going to be 2, and it's going to go all the way up to 255. Then it's going to be 0 again. Okay, so then we fill up the array, and when it gets full, then we start to fill up from the beginning, which should kind of make sense. So now the earlier ones are going to disappear after we get 255. So let's run the game. And now if we make skid marks, then they should start disappearing from the end when we get 255 of them, which is pretty damn cool. Although I don't really want it to be circles like this. I'm not sure what happened there. Segmentation fault. Skid mark count will get higher and higher. So we're going to start reading into the unallocated memory, or the memory that we haven't allocated. So how do we fix this? So skid mark count should never go over 255. So there's a difference between the skid mark count and the skid mark index. Can I make them null? If I do something like this, but is this only for pointers? Can I zero this out? And then if I do 255, which is the number of skid marks, then can I check if this is null? I don't think it's going to be null. Let's first of all try to compile this. Maybe it will say that you're doing something wrong, but it's not saying that. So if skid mark is not null, then we're going to do this. I mean, but it's not null because it's a skid mark. It's a skid mark struct. Why am I being so stupid now? So, what is the proper way of doing this? So we don't have to initialize anything here. We can just do this. Skid mark count 0. So then we loop through all of the skid marks, but we shouldn't go over 255. So we could just add here and I less than 255. But I feel like this is not the right way. I don't like this approach, but it should work now. So we shouldn't get a segmentation fault now. It should just stop drawing the circles, and we should be able to just drive around as long as we want and make donuts here, and it's just going to work. But now one thing is that I don't want them to be circles like that. I want them to be closer to each other. But I'm not sure how I can do that, because isn't this drawing it on every frame? So how can I make them closer together if they're drawing already every frame? That's a bit weird. Well, anyway, we can now draw some sort of skid marks. And let's in fact draw the car after the skid marks. That probably looks a bit better. And we want to only draw the skid marks when we are drifting. So how do we do that? To detect whether we are drifting, we could calculate the difference between the drift angle and the car angle. So we can say that the float drift diff is going to be drift angle minus car angle. And then we can say bool drifting is if the absolute number of drift diff is greater than something. Let's say 40 degrees. That means we are drifting. Okay? So then, if we are drifting, then we are going to do all this stuff. And actually all this stuff as well. But now we don't have a mechanism to remove the old skid marks, right? So they'll just stay there until we get 255 skid marks. But now, if I drift, then we have skid marks, but otherwise we don't. Okay, that's pretty cool. So now we can make donuts. That's pretty cool. Okay. That's awesome. Maybe it can even start earlier. So let's say drifting is, let's say 30 degrees. So now if we just don't turn that much, it doesn't make skid marks, but sometimes it makes skid marks when we make donuts. That is pretty cool. So what's next? We should somehow make them nicer, because I really want to have skid marks that don't have holes in them. You know, I want it to be a straight line, which might be difficult. Because, yeah, is there some way in Raylib to make like a shape from multiple different points? Maybe. That's pretty cool. But this video is starting to be too long. So what I will do to finish this video is I will make the skid marks disappear over time. Not only when it like goes over the maximum skid marks. We should probably say that the 255 is going to be max skid marks. So let's define that sort of thing up here. Define max skid marks. So then we can even make it higher, like 500. But then I need to somehow determine when to destroy the skid mark. I kind of want it to be based on time, or it could be based on frame. Well, not really. It's not good to base it on frame. Let's base it on time. So what we can do is we can add an int, which is time, right? And then when we create the skid mark down here, we add the time when we created it. How do we get time? I think we can like import time, include time.h, and can I actually even use time? I think I can use time. Is there a function called time? Is that it? Is there a time? Return the current time and put it in timer if timer is not null. Return the current time and put it in, okay, whatever is star timer. And this is a time t. Okay, I wonder what it is. Time t. Can I cast it into an integer? What is time t? Can I say that this is going to be time t? And what is time t? Long. It's a long. Okay, so a long is just a number, right? So we have a time t, and I would guess that that is like a Unix timestamp, hopefully. So then, what does it want? It wants the timer. It wants the timer. Wait a minute. Time t star timer. What? Let's go to the definition. And put it in timer if timer is not null. So we can use null here. We don't want any timers. We just say time null. Okay. And is it the time from the beginning of the execution or the Unix time? I don't really care. So I can do here, when we loop through all of the skid marks, we can say that time t current time is time null. And if current time minus skid mark time, current time is going to be greater, yes? If this is greater than, I don't know, 5 seconds, then we are going to, we can just continue. We don't have to care about that one. Now, we could delete it or something, but why? We don't have to delete it. And we can call this skid mark time. So let's define skid mark time as 5 seconds. Then we build it and we run it. And now we don't have any, we have skid marks because they only start when this thing starts to skid, but they are not being removed for some reason. They start to be removed, but I think it wasn't because of the time. So let's do this. Where are we doing time? There's probably a time function in Raylib too. So here we add a skid mark. We can just do here printf. Can we just print as a float? And we can say time is this, and we put the current time there. So what? Oops. Oh, it's a double. So we have to do LD. Okay. Maybe that causes some issues. Okay, so what is it now printing? It's printing nothing. Okay, so that is literally a Unix timestamp. But We are not going here anywhere, any time. Maybe because it is a time t, so we need to cast it into a double or something. So if I do this, 1, 2, 3, 4, 5. Okay, it's starting to kill them. Oh, okay. Okay, that's fine. So it works. It's just too long. So I don't need it to be that long. Let's do just 2-second skid marks. But this is not good enough. We need micro time. There's no micro time in this one. Is there like a millis? Is there something about milliseconds? How can we get the time in milliseconds? Because these are all created at the same second. Let's ask ChatGPT. I didn't ask ChatGPT anything yet in today's video, so let's ask something. How can I get milliseconds in C? Time with H. Get time of day or clock get time. Okay. Long milliseconds. Struct time val TV. What? Can I get it easier with Raylib? Yes. Get time. Okay. And that is going to be seconds as a float. Okay, so I'll just use that one. So we don't have to use time. We just use get time. Get time. Like this. And this returns a double. Okay. And the current time, which is now a double, is going to be get time. And then if that time is greater than skid mark time, then we're going to continue. So then this is going to be a double time. And I think that is all, is it? I think that is all. So let's now build it and run it. And let's make some skids. And wait 2 seconds and they should start disappearing. Look at this. Now they disappear exactly the way I want them to disappear. Which is kind of funny, but yeah, it works. No problem. Maybe they're too long even. I don't know. I don't know what is the point of skid marks. So let's just put 1 second so we can see what happens. If we make a donut here, it starts to disappear already. So now we can't really make donuts because they disappear before we can make them. But that's pretty cool. So this is now going to be the end of today's video. I hope you enjoyed it and let me know in the comments what direction I should take this game. I think next we should add some road to this game and make it actually playable so that we can drive on the road. Anyway, subscribe if you want to see more videos like this in the future and leave me a like and I'll see you in the next one. And I'll keep making donuts in my beautiful 2D racing game here. Thanks for watching.